There's a very specific frequency of silence that happens when you put two deep experts in a room.
Hmm.
You probably heard it, even if you didn't recognize it at the time.
Hmm.
Say you're at a dinner party with a specialized cardiac surgeon and, I don't know, a structural engineer.
Two people who are arguably at the absolute top of the food chain in their fields.
Exactly. And when they stay in their lanes, when the surgeon talks about aortic valves or the engineer talks about load-bearing concrete, the air is just electric.
Right. They're precise, dominant,
Absolutely safe.
because they are operating within the boundaries of their certification.
Right. But the moment the topic drifts, say, they start discussing the physics of flow or how complex systems fail in general, the energy in the room just changes. The conversation, as the author we're reading today puts it, it gently contracts.
That phrasing is incredible. It comes from Lev Motin. It's the opening hook of his essay, Breakthroughs on Boundaries.
And it's not like an angry silence. It's not an argument. It's a polite withdrawal. And Motin describes this exact dynamic with a close friend of his, a really accomplished physician. And this friend dropped a word during one of these silences that basically sparked this entire deep dive.
Okay.
He called anyone operating outside their certified narrow training an amateur.
Oof.
And in his world, that is definitely not a compliment.
No. In high-stakes medicine, amateur means dangerous. It means incompetent. It implies someone is going to get somebody killed.
But Motin didn't take offense.
No. He took it as a signal. And he uses that specific friction point to crack open this massive question. What actually gives knowledge its authority?
It's that tension, right, between depth and breadth. Is authority about knowing every single millimeter of your silo?
Or is it about the ability to connect that depth to the messy, unauthorized world outside of it?
Exactly.
So today, we're exploring the edge of expertise. We're going to unpack why these silos we built for safety are maybe, just maybe, stifling the next wave of discovery.
We'll be looking at the history of physics, the culture of aviation versus medicine, even the future of AI, all to understand why the most important person in the room might be the one who doesn't quite belong there.
But, to really understand the power of the amateur, we have to start by defending the expert, because that physician friend, he isn't wrong.
I was going to say, if I'm on an operating table, I absolutely do not want a passionate amateur holding the scalpel.
No, thank you.
I want a generalist nowhere near me. I want the person who has done this exact procedure 5,000 times and cares about nothing else in the world.
Precisely. And Motin acknowledges this right up front. We have to be realistic. Modern knowledge, whether it's medicine, nuclear physics, chemical engineering, it's just too vast for the old Renaissance man model.
The era of Da Vinci it's over.
It's over.
You can't just wake up and decide to master biology in the morning and, engineering in the afternoon.
The cognitive load is just way too high. So we build silos, we fragment knowledge into these manageable disciplines.
And specialization gives us reliability.
It gives us accountability. If a bridge collapses, you need to know exactly which structural engineer signed off on it. You don't want a philosopher who dabbles in cement.
So the silo is, first and foremost, a safety mechanism. It's about mitigating risk.
It is. But here's the paradox that Motin points to. We have confused safety with progress. We operate under this quiet assumption that the cure for cancer will come from oncologists doing more oncology, or the next leap in energy storage will come from electrical engineers just refining the grid.
But if you look at history, it's statistically unlikely.
History shows us that while refinement happens in the center of the silo, breakthroughs happen at the borders. The truly transformative leaps almost always bubble up from the edges, where the rules of one field start to break down and you are forced to go steal tools from a neighbor.
Okay, so let's get into the mechanics of this, because Motin brings receipts. The historical examples here are fantastic, particularly the story of Michael Faraday and James Clerk Maxwell.
This is the archetypal clash. It's the amateur spirit versus the establishment.
And for context, for anyone who might have slept through Physics 101, Faraday is a legend now. We name laws of physics after him.
Right.
But in his time, he was viewed with a lot of skepticism by the academic elite. He wasn't a gentleman scientist. He was a bookbinder's apprentice.
And critically, he was illiterate in the language of physics at the time.
Which was math.
Faraday had almost no formal mathematical training. He wasn't solving differential equations. He was playing with magnets and wires and iron filings.
He was a visual thinker in a purely mathematical world.
Right. When he looked at a magnet, he didn't see numbers. He saw lines. He visualized these invisible fields curving through space.
But because he couldn't write the math to prove it?
The establishment just kind of patted him on the head. His work was considered qualitative. Interesting, sure, but not real physics because it lacked the rigor.
It was amateur work.
Exactly. Then, enter James Clerk Maxwell.
The translator.
Maxwell is so interesting because he was the ultimate border crosser. He was a rigorous mathematician, fully accepted by the establishment, but he didn't dismiss Faraday's amateur visions.
He respected them enough to try to translate them.
He took the pictures that were in Faraday's head and turned them into the equations that, literally run the modern world.
And that is the key takeaway, isn't it?
It is. Neither of them could have done it alone. Faraday had the vision but lacked the syntax. Maxwell had the syntax but needed that initial spark.
So the breakthrough wasn't inside physics or inside math. It was in the translation between them, which implies that if those two hadn't met, or if Maxwell had been too arrogant to even look at the work of an amateur, we might have waited another 50 years for electricity.
Easily. And this whole dynamic, this idea of importing a breakthrough, it leads to another pattern named Moten highlights, which I think is even more relevant today. It's the idea that tools often arrive before theories.
This really messes with the standard scientific method model we all learn in school, doesn't it? We're taught hypothesis, theory, experiment, tool. It's supposed to be this neat, linear process.
But in the real world, it's so often the complete reverse. A machine gets built for one purpose, usually by engineers just trying to solve a practical problem, and it accidentally revolutionizes a totally different field that had no idea it even needed it.
The prime example being X-ray crystallography.
Exactly. This was a technique from physics. It was about studying the diffraction of light through crystals, rocks, basically.
It was never designed for biology.
Never. Biologists didn't ask for it. It wasn't in their budget.
But when that tool migrated, when it crossed the border from the physics department over to the biology department, it revealed the double helix structure of DNA.
Biology didn't advance because its own biological theory suddenly got smarter. It advanced because it absorbed a guest tool.
Moten calls them guests. It's such a polite way of saying invaders.
It is. It's beautiful imagery, but it implies hospitality. And that's the rub. Think about medical imaging, CT scans, MRIs. These are nuclear physics and signal processing technologies. Medicine is just the host. But hosting a guest requires you to open the door.
And if your entire identity is wrapped up in being the all-knowing expert, opening the door looks a lot like admitting you don't have all the answers.
Exactly. If I have to borrow a tool from you, it subtly implies my tools aren't good enough. For a mature field that prides itself on authority, that kind of vulnerability is painful. It creates resistance.
Which brings us to a field that seems to have zero ego about this, mostly because it never really had a home to begin with. Let's talk about computing.
The ultimate mutt discipline.
Right. Moten argues that we treat computer science like a silo now.
Yeah.
It has its own departments, its own degree.
Its own tenure track.
But it's actually a scavenger.
Think about its DNA. Where did it come from? Its logic comes from pure mathematics. Its hardware is electrical engineering and material science.
Its software concepts borrow heavily from linguistics and Noam Chomsky's grammars.
Early AI was explicitly trying to mimic neurobiology. It's a total Frankenstein's monster of other fields.
And just look at the hardware running the current AI boom. GPUs.
That's my favorite connection.
It wasn't some high-minded scientific ambition that built the chips for ChatGPT. It was teenagers wanting higher frame rates for Call of Duty.
And that is Moten's entire point. Computing wins because it's homeless. It was forced to be interdisciplinary from day one.
It never had the luxury of saying, this is our turf, stay out.
It had to scavenge from everyone else.
It's an amateur field by definition.
Yeah.
It loves the utility, not the pedigree.
Yeah.
It just doesn't care where the idea comes from as long as it compiles.
And because of that promiscuity with ideas, it became the connective tissue for the entire modern world. It's the universal translator.
But not every field is as welcoming as computing. And this brings us to what I think is the most tense part of the source material.
The clash of safety cultures?
This is where the rubber really meets the road on that amateur label.
Yeah, this section is the intellectual core of the essay. He compares the safety culture of aviation and nuclear engineering against the culture of medicine.
We tend to lump these together as high-stakes fields. People die if you mess up. But their whole approach to failure is diametrically opposite.
In aviation, failure is viewed as a system property. If a plane crashes, they don't just blame the pilot.
Right.
They assume human error is inevitable because humans are flawed biological machines. So they built checklists, redundancy, defense in depth. They design the system to catch the error before it's catastrophic.
The pilot is just a component in a much larger safety architecture. A vital one, sure, but a fallible one.
Right. But medicine. Historically, medicine is a craft of individual judgment. The physician is the hero, the expert. Excellence is personal.
So conversely, failure is personal.
Exactly. If the patient dies, it's not because the system failed. It's because you weren't good enough. You missed the diagnosis. Your hands weren't steady. It's a burden of individual perfection.
So what happened when aviation tried to export its tools to medicine, specifically the pre-flight checklist?
Friction. Massive friction. When checklists were introduced to surgery, simple things like confirm patient name, confirm correct limb, the data was undeniable.
It worked.
It worked immediately. Mortality rates dropped. Infections dropped. It saved lives. But adoption was incredibly slow.
Why? I mean, if you're a doctor and you see data that says this saves lives, why on earth wouldn't you use it?
Because the checklist threatened the very identity of the expert physician. A checklist feels like something a novice uses, a student.
For an amateur.
An amateur. The resistance wasn't technical, it was psychological. The question became, if I need a checklist, am I really the expert?
That is the dangerous side of the silo. The mask of expertise becomes more important than the actual outcome. It's about protecting the ego rather than the patient.
And that is precisely why Moten wants to reclaim and redefine the word amateur. He dives into the etymology, and it's just perfect. It comes from the Latin root amare. An amateur isn't someone who is bad at their job. An amateur is someone who does it for the love of the pursuit, rather than for the certification or the status.
It's the person who is willing to look stupid in order to learn something new.
And Moten redefines the amateur as the person willing to step beyond their competence. And then he delivers this philosophical punchline that I think should be on a billboard.
Go on.
He says, the real weakness is not curiosity without expertise. The real weakness is expertise that no longer permits curiosity.
Expertise that no longer permits curiosity.
Wow. That explains the silence at the dinner party, doesn't it?
It does.
Yeah.
When the conversation drifted to physics, the physician stopped talking, not because he was bored, but because he was afraid. When you step to the edge of your field, you lose your institutional protection.
You aren't the doctor anymore.
You're just a guy guessing. It destabilizes the hierarchy. It forces you to be humble.
Specialists refine things. They make the engine 1% more efficient. But amateurs reframe. They look at the engine and ask, why aren't we using a sail? And yeah, sure, 99 times out of 100, that is a terrible idea.
But that one time
Is the breakthrough.
So if we look forward, if we embrace this amateur spirit, where does Moten think the next big collisions are happening? Because he lists a few specific intersections that are heating up right now.
He does. And notice, none of them are single fields. The first one is the collision of medicine, engineering, and data.
Which goes right back to the checklist discussion.
It's moving health from an art to a system. It's about modeling the human body the way we model a complex aircraft or a weather system. It requires doctors to think like engineers and engineers to understand biology.
Then there's one that I think is the most urgent and maybe the most technically constrained. AI meets physics meets energy.
This is huge. We're reaching the point where our desire for better AI is hitting the physical limits of the universe.
It's not about writing better Python code anymore.
No, it's about how much heat a silicon chip can dissipate before it melts. It stops being a coding problem and becomes a thermodynamics problem.
It becomes material science.
Exactly. The next ChatGPT isn't going to come from a software developer working late. It's going to come from a physicist inventing a new semiconductor material that runs 10 degrees cooler. The bottleneck has shifted entirely.
He also mentions the dissolving line between biology and robotics.
We see this everywhere with neural interfaces. If you put a chip in a brain to cure Parkinson's, is that biology? Is it electrical engineering?
It's neither.
It's the silence in between. And it requires a shared language that doesn't really exist yet.
And finally, the moral frontier. Human judgment meets automated systems.
This is where the philosophers and lawyers have to crash the party of the coders. Who is responsible when the AI drives the car off the road? How do we maintain human agency in a loop that's dominated by algorithms?
You can't code your way out of a moral crisis.
And you can't engineer your way out of a legal one. These problems require a shared language. And right now, we don't have one.
Because everyone is still sitting at their own table. The coder is coding, the lawyer is litigating, and the philosopher is, well, philosophizing.
Exactly. We
Wow.
need the translators. We need people willing to be amateurs in multiple fields to build that connective tissue.
I want to bring this back to the start, though. Back to Moten and his friend at the dinner table. Because after tearing down the concept of the silo, he finishes the essay on a surprisingly tender note about that physician friend.
He does. He circles right back to that silence. He says that when he talks to his friend now and the topic drifts and the friend goes quiet, he interprets it differently.
He doesn't hear arrogance or dismissal anymore.
No, he hears care for depth.
Yeah.
He realizes that his friend's hesitation comes from a lifetime of high-stakes responsibility. That caution is what keeps patients safe.
It's what prevents science from becoming just wild speculation.
It's a respect for the weight of truth.
Right.
So the lesson isn't burn down the silos.
Right.
We need the experts to guard the center. We need the rigor. We need the person who knows exactly where to cut.
Right.
But we also need the amateurs to patrol the borders. We need the people who aren't afraid to look foolish, asking why.
We need someone to notice what the field itself cannot see.
The future belongs to those who understand where the fields strain and break. It's about having the expertise to be rigorous, but the curiosity to be a beginner all over again.
It reminds me of that famous line from Suzuki on Zen. In the beginner's mind, there are many possibilities, but in the experts, there are few.
A perfect parallel.
So here's the challenge we want to leave you with today. Think about your own work, your own profession. Where is the silence?
What is the topic or the tool that when it comes up in a meeting, everyone just kind of shuts down or rolls their eyes? Oh, that's not what we do here.
That's for the marketing team or that's for the engineers. Where is that line you are afraid to cross because you're terrified of looking like an amateur?
Because if you can identify that silence, that is likely exactly where your next big idea is hiding.
Go find your silence. And maybe, just maybe, be brave enough to ask a stupid question about it. Thanks for diving in with us.
Keep exploring.